In the tree lines of Eastern Europe and the skies over the Gulf, military strategy is being rewritten with duct tape and commercial quadcopters. Soldiers take off-the-shelf drones, stripping them down and wiring them for autonomous combat. A swarm of these low-cost, algorithmically guided machines can overwhelm and neutralize a multi-million-dollar heavy tank or an advanced air defense system. The raw cost asymmetry is making traditional heavy armor obsolete. This animation represents the story we hear most often about this technological shift. We see two racing bars, the United States and China, locked in a winner-take-all sprint to build the ultimate supercomputer. This data tells a different story. The global landscape is a collision of three distinct geopolitical philosophies. The US versus China bar chart zooms out to reveal India as a crucial third player, forming a tripolar map connecting Washington, Beijing, and New Delhi. Each nation navigates its own specific structural limits. These three nations are running entirely different races, and their distinct strategies will dictate the future of global power. The American strategy is built on pure scale. Fueled by trillions of dollars in private venture capital and hyperscaler tech monopolies, the goal is artificial general intelligence, or AGI, a system capable of outperforming human cognition across the board. On the battlefield, this translates into programs like the Department of Defense's Project Replicator. The military intends to field thousands of attritable autonomous systems, drones and software agents cheap enough to lose, but smart enough to act without human direction. To maintain that speed, the US prioritizes unconstrained innovation. Recent deregulatory moves have rolled back previous usage constraints, clearing the path for private companies to build and deploy models with fewer friction points from the federal government. But the American model has a severe physical limit. Training frontier models requires massive data centers that demand gigawatts of electricity, straining a national power grid. Furthermore, the entire talent pipeline relies heavily on the continued influx of foreign-born engineers. The United States is attempting to outspend and outcompute global problems, but it risks hitting a wall built by its own immense physical energy demands. China, meanwhile, operates under a different imperative. Locked out of Western semiconductor supply chains, Beijing focuses intensely on algorithmic efficiency and self-reliance, trying to squeeze maximum performance out of older, domestically produced microchips. To achieve this, the state relies on a strategy called military-civil fusion. In China, the firewall between private commercial technology labs and the People's Liberation Army simply does not exist. Civilian breakthroughs are military breakthroughs. This creates a doctrine Beijing calls intelligentized warfare. They are channeling resources into embodied AI, putting algorithms into physical machines like quadrupeds and humanoid robots, aiming to automate physical logistics and military command loops entirely. Yet their hardware bottleneck remains severe. Despite clever software optimization, China still lacks access to the most advanced extreme ultraviolet lithography machines required to manufacture cutting-edge silicon, and strict capital controls limit outside investment. Beijing is now engineering a highly resilient physical tech ecosystem designed to operate entirely outside of US influence. But in doing so, they risk permanent isolation from the collaborative global tech supply chain. India operates on a third track, an enable then regulate philosophy. Instead of relying on a handful of private monopolies or absolute state control, New Delhi builds open-source digital public infrastructure. They provide the foundational digital layer, then allow private companies to innovate on top of it. This chart highlights the severe financial asymmetry. While the United States allocates over $13 billion specifically for defense autonomy and AI, India operates with a dedicated military AI budget of roughly $46 million. They play the game with a fraction of the capital. To compensate, India pushes its private defense sector to iterate rapidly. Local startups are currently building autonomous aircraft and exporting them to NATO countries, proving they can produce cost-effective hardware for the global market. Scan the bottom rows of this table detailing global military AI systems. You'll see India's operational border defense technologies. To deploy these systems responsibly, India introduced the Evaluating Trustworthy AI, or ETI framework. It is a set of rigorous operational risk-based assessments designed specifically for military algorithms. ETI operates on a strict compliance standard. It mandates human-in-the-loop oversight for high-risk decisions and forces algorithms to undergo out-of-distribution testing, ensuring the system won't act unpredictably when it encounters data on the battlefield that it never saw in training. India is actively testing whether heavy operational governance can coexist with rapid deployment, attempting to secure its borders without sacrificing human oversight. The global AI arms race functions as a civilizational stress test. The victor must navigate specific structural bottlenecks: the American energy grid, the Chinese chip supply, or the Indian R&D gap. This policy document captures the core anxiety of the moment, outlining the strategic risks of falling behind. That fear is pushing both the United States and China toward a race where ethical guardrails are abandoned for speed. Meanwhile, dozens of resource-constrained middle powers are watching. They urgently want to integrate intelligent systems into their militaries, but they cannot afford the American price tag, and they do not want to adopt the strict isolation of the Chinese model. What they need is a functional, affordable blueprint. India is now operationalizing risk-based assessment under these extreme border constraints. If they maintain reliability here, they provide a blueprint for a global community balancing military modernization with severe resource asymmetry. The nation that successfully exports its governance model will win this race. Success will be determined by who establishes the global rules for how these machines are used.